Hi, everybody. This is Logan Petzar. I'm here with Tom Baldwin and Bartricia Williams. We're here to show off our app. This is the geolocation project is what we wanted to do. We originally had decided to use something with geolocation and eventually sort of landed on being able to search a doctor, something around your location that would come up and let you know if it was supported for either Medicare or your insurance type, that kind of a thing. So we intended on using two different APIs. That would be the health care provider API. In this case, we stuck with Medicare, and then the Google API, and that would use maps, searches, that kind of a thing as well. Here to talk about some of what went into this and show off the app. I'm going to send it to Tom, and we'll go from there. Tom?
Hi, everyone. Yeah, so this right here is the GUI for the map. So basically what we decided to do is we started out thinking we would have two different input methods, one being a manual coordinate search or possibly name search, so that the user can have some input over exactly where they want to search for healthcare providers that might be covered. And then also an option to search using their current location, either via current location on a mobile device or using Google API, potentially checking current location over your Wi-Fi connection location. What we ended up doing as a result of some time constraints, and we ended up cutting the current location, so you can see that button is currently grayed out. And due to some of the inputs that we'll talk about later that are required for the Medicare API, we ended up settling on requiring a full street address of the healthcare provider and the zip code of the healthcare provider in order to check if they're supported, if they support Medicaid or Medicare, excuse me. So initially the idea was that we would try to search for a range of providers in an area. But again, just due to time constraints and some very specific ways we had to search using the Medicare API, which Bartricia will go over in a little bit, this ended up being what we kind of had to do in our stripped down version of the app. The majority of the screen, and it's fully responsive and dynamic as best we can do. The majority of the screen is taken up by this web view window here, which is just displaying a Google Maps URL. By default, we just pull up the default Google Maps URL, which typically is going to just show the user's current location. And then for the controls up here, we have it set so that they have to enter the full street address and zip code of the healthcare provider currently. So if I click search without doing that, we'll get a quick little warning message. If you have partials or either field is empty. As long as you have data in both fields though, it will try to do a lookup of the healthcare provider. And just to demonstrate that real quick here with one that we know is covered offhand, if I do this, it's going to say Medicare is accepted, and it's going to pull up the Google Maps address here. Normally it would actually take us right there and show us the street view here as well. It doesn't look like this one is doing this for some reason right now at this moment. And then if we wanted to do another one just to show what happens if there's an entry that it can't find a match against Medicare for, which could be a health practitioner's office, or it could just be that they entered something that is invalid, like home address. It'll still update and take you to that location, and it'll say Medicare is not accepted. So to go over a little more how we're doing this search part here, I think I'll pass it over to Bartricia, and she can talk about the coverage verification that we're doing. Bartricia?
Okay, well, hey everyone, this is Bartricia Williams, and I will share with you all basically how we use the Medicare API to verify coverage. Let's see, we'll share my screen. So how we went about this originally, it was going to the data.medicare.gov site, and the Medicare site participates in the Socrates Open Data API. So this is an open API that is available We looked at a couple of other providers of data, and they were either privatized or there were a lot of issues with getting an API key. So given the constraints of time for this particular project, we decided to stick with the data at Medicare.gov. So as you can see, there's this one particular data set that we have using the zip code to search, and this API has this particular data that comes back, very specific, but the parts that we were interested in to work with the API that we're with the GUI that we're developing is using the street address that is in Medicare and the zip code. And when we get the address passed into the Medicare class, the file checks to see if the address and the zip code that was passed, does that address and zip code exist in Medicare.gov data set? If it does not, Medicare is not accepted at the location. If it is found, the Medicare data is accepted at that particular location. So to just go down into the code that we have, once we access the URL here, which is the API, and we're going based on the zip code that is passed into this particular class, using that zip code and then connecting to the Medicare API server, what we're looking for is we're getting the Medicare address, and then we're just checking a Boolean value to see that if the address passed in matches up with the Medicare address that was received. And if it does, our response back is going to be true, and if it is not, our response is going to be false. And from there, we handle it with the Google API. So I'll pass it back to Logan.
Yeah, so let me share my screen here. And okay, so what we had originally planned on doing, like Tom had mentioned up at the top, was we wanted to be able to search for the location and have it come up with, you know, a string of locations around you that can be used and searched for Bartricia's API with the Medicare side. So I had built something that basically the way that Google API works is a lot of it is done through just this URL up here. And there's different types. There's text search, there's place search, there's different functions that that Google can use, and it's all well documented and pretty robust. And we had made a way that we'd be able to search, get the data back, and pull out exactly what we needed, because for Bartricia's search to work, we needed that address line and we needed a zip code. So the problem is that when you run this this query, I'll send this over here, this is the data that you get back. So what we're doing in this is we're doing a text search for anything around this address, and then we can do something like, let me bring this back up, what's called a type search. So we're looking for anything that's a doctor, we're looking for a radius of 1,000 meters, and then we have our API key at the end. So what we needed to do was take that data, parse that out, and pass that along. So I was looking into using the XPath function, which is basically a way to take an XML file and format it down to what you need. So Google had, fortunately, they had some documentation on how to do this and get exactly what we needed out. So I was running it through this, and we were taking just the formatted address field. So if I go back here, you can see this is what we were getting back. Now, the problem that we ran into with that was we needed to pare that down even more for Bartricia to use. So I was working on basically doing this in such a way that I would get two separate arrays. There would be one array for the address, one array for the zip code, and then she would be able to pass that along. So the first address that I had here going for address, this would take anything that was after the first comma in the line, take that out, and then save that as an address. And I'll pull this over here so you can see. So that would essentially give us that first line of the address that we needed. And then the second one for the zip code, it would take the same string, and then it would, you know, take the last 15 characters out, which would remove the United States from the end. And then it would shorten it to just 5 characters, which would take everything before that from the end. and then give us the zip code. So if we run it, you can see I have it set to print the data out. We would get two separate arrays. One would be the address line, one would be the zip code line. Now the problem that we had with this was just sort of a unfortunately time constraints. We weren't able to fit this in, but this would be the next version of the AMP if we had more time, if we had more manpower to work on this to get this done. This was sort of the ultimate goal of the AMP, but we decided to settle on what we showed you earlier. So doing that, we were just able to use the URL function in that web view that Tom showed up front to display the map, put the point on the map, and then go from there. So I believe that's the app. Did you guys have anything else you wanted to go over for your parts?
Yeah, I think if I can share my screen again here, I was going to go over a little more about the specific tech we used for building the GUI, I guess, since I didn't really go over that very much.
Sure. Yep. Here, I'll stop mine.
So in order to actually build out the GUI, we use JavaFX. So JavaFX used to be included by default with Java Development Kit and Java SDKs. And as of, I think it's Java Development Kit 11 and above, you have to include it as a separate package or separate import. So what we did just because of time constraints is we just said, well, for simplicity, we're just going to import this with an older version of JDK. So using either Java Development Kit 8 or up, we built this out and just imported JavaFX methods directly from and packages directly from the Java Development Kit on that version. So the way that it's built out is that this here is actually the main method for the whole application. And all that it does is it really goes and creates a JavaFX stage containing a scene and some other data that's built upon the foundations of how this FXML document is laid out. And similar to like a XAML document or things like that in other programs and applications, it's basically just like an artifact, nearly XML-like, that basically dictates in the app where everything is placed. So you can see just looking at this at a glance, there's XY coordinates that determine the layout. And the way that we built this was using Gluon Scene Builder, which has a nice GUI methodology of putting buttons in places and things like that. We're able to define all this kind of automatically, and adding additional things like some of these ID tags that are used, I'll explain later, doing that by hand. So then this actually, so again, this gets called here in the main, and in the map controller.java, which has the main down here, and this just launches the app. But really all the triggers for what you do when you push a button that's calling that, what's in that FXML file, is all controlled in this document controller here. So for example, this method right here is what gets called when you push that search button up on the top left. And so then we can basically do all the checks with Medicare, make a Google Maps URL, and throw that open in the GUI, all within here. There's a couple other methods in here as well, but this is kind of the meat and potatoes. Is when you have button clicks, this triggers events from this class here. And I think that's really it for me.
Okay, sounds good. Anything else, Bartrucci, you can think of?
Yes, I'll actually add one more thing, and that is, let me pull it up here, and that is with respect to the Medicare API. So a question some people may be asking is, why is it that we decided to just use one street address field and kind of key off of the zip code? What we sort of noticed here is that not all APIs are the same. The Google Maps API is much more robust than the Medicare API. sometimes when we would make calls, sometimes all the data wasn't returned, sometimes one row of data was returned. Even when we did a query exactly as the API stated to just get the street address, we wouldn't get any data back, as opposed to if we did a query by state, we would get data back. So just to say that we had to be kind of inventive about and more limited to what fields we could use to query on due to how inconsistent that the Medicare.gov API could be. But I would also say perhaps going forward, because that data set is available, is to possibly pull that data in one pull and just pull that to a separate database and just update regularly as necessary.
Right. Yeah, the nice thing working with the Google stuff on my side was it supports, you know, fuzzy searches, so you can type something in that would be close but not exact to what they have on the database, and it would still bring the same results. So that's why when it came to this, we needed to make sure that what we were getting back was formatted exactly to the way that the Medicare API was looking for it, or else it would all turn up false. So that was definitely another issue working with the two that we had to contend with. But yeah.
Okay, and that's all I have.
All right. Well, that sounds good. Thank you for sitting with us and taking a look at the app. Thank you both for your hard work on it, and wish you guys the best of luck.